Welcome to the DIY Honda Garage channel. The DTC P0721 indicates an issue with the output shaft or countershaft speed sensor in the Honda Accord models from 2017 through 2023. This fault occurs when the sensor's output readings are out of the expected range, indicating possible issues with the vehicle's speed feedback to the powertrain control module, PCM. The output shaft speed sensor is crucial for ensuring smooth transmission operation and helps the PCM determine the optimal shift timing. When the sensor fails or produces inconsistent readings, it can lead to suboptimal shifting and can even cause the check engine light to illuminate. It is located near the vehicle's transmission system, where it directly monitors the rotation speed of the output shaft, thereby providing critical data for effective vehicle operation. Proper diagnostics and troubleshooting are essential to assess and repair this fault effectively. The output shaft or countershaft speed sensor plays a significant role in vehicle performance by monitoring the speed of the output shaft, which is linked to the transmission. This sensor provides crucial data to the powertrain control module, PCM, allowing it to make informed decisions for timing shifts, optimizing fuel efficiency, and improving vehicle control. Located on the transmission, it's typically positioned where it can accurately gauge the shaft's rotational speed. A malfunction in this sensor not only triggers DTC P0721, but can also lead to erratic shifts while driving, impacting both the performance and safety of the vehicle. Hence, understanding the sensor's operation and its implications on vehicle dynamics is essential for effective troubleshooting. Several factors may cause DTC P0721 to manifest in your Honda Accord. Firstly, issues with the wire harness connecting the output shaft speed sensor to the PCM can disrupt normal sensor operations. A damaged or corroded wire may result in signal interference or outright failure, preventing accurate readings. The second possible cause is a faulty output shaft speed sensor itself. If the internal components are worn or damaged, the sensor won't provide correct speed readings. Another consideration is potential issues with the PCM, which could lead to incorrect interpretation of the sensor's data. Each of these causes must be thoroughly examined to identify the root of the problem effectively. Various symptoms may imply the presence of DTC P0721 in your Honda Accord. One of the primary indicators is the illumination of the check engine light on the dashboard, triggered by the PCM detecting the fault. Erratic transmission shifting patterns are another common symptom, which occurs when the PCM lacks accurate speed data to determine the right shifts, leading to potentially harsh or unexpected gear changes. Additionally, you may experience poor acceleration performance due to incorrect gear ratios being employed, further exacerbating the issue. It is crucial to address these symptoms promptly to avoid more significant complications in the transmission system. The first step in troubleshooting DTC P0721 requires you to verify the problem effectively. Begin by starting the engine and holding the engine speed at approximately 3,000 RPM while the vehicle is in neutral. This process allows for the activation of the radiator fan, ensuring that the engine reaches stable operating conditions. After holding it for this duration, drive the vehicle for several minutes to replicate normal operating conditions. Next, utilize the Honda Diagnostics System, HDS, to check the parameters associated with the output shaft speed sensor, particularly looking for any signals indicating vehicle speed. If the readings show that vehicle speed is indicated, you may be facing an intermittent failure, suggesting that the wiring or connections may need inspection. Conversely, if there is no indication of speed, the failure is active, and you should proceed to the next troubleshooting step. In Step 2 of troubleshooting DTC P0721, You begin by turning the vehicle to the off or lock mode to ensure safety during the process. Next, disconnect the 3-pin 3P connector associated with the output shaft countershaft speed sensor. This disconnection helps facilitate a clear measurement of electrical signals. Following this, change the vehicle mode back to on, but keep the sensor disconnected. It is essential to measure the voltage between test points 1 and 2 on the sensor connector. Specifically, you will be assessing the voltage between the female terminals number 1 and number 3 using a multimeter. You are looking for a voltage reading of approximately 5.0 V. If you receive that reading, it indicates that the circuit is functioning correctly, and you will proceed to the next step. If not, you will move on to examining possible circuit faults. Step 3 focuses on checking for an open wire in the VCC1 line. Start by measuring the voltage again between test points 1 and 2 with the vehicle in on mode and the sensor connector still disconnected. Here, you must measure the voltage across terminal number 3 of the speed sensor connector against a solid body ground. You are aiming for approximately 5.0 volts here as well. If you get this reading, it confirms that the VCC1 power supply wire is intact. In this case, you will likely focus on repairing any open circuits in the SG1 signal wire that runs between the PCM and the output shaft speed sensor. Conversely, if the voltage is not as expected, it indicates an issue with the VCC1 wire itself. In this scenario, you should work on identifying and repairing any open circuits in the VCC1 wire for effective troubleshooting. In step 4, you will determine if the problem lies with the output shaft speed sensor itself. Begin by making measurements similar to the previous steps. Specifically, you will measure the voltage between test points 1 and 2 while the vehicle is in on mode and the sensor is disconnected. This time, focus on terminal number 2 of the speed sensor connector and compare this against a body ground. Ideally, you should observe a voltage reading of approximately 5.0 V. If this reading is present, it signifies that the output shaft speed sensor has malfunctioned and needs to be replaced for proper operation of the transmission system. If the voltage reading deviates, there could be other underlying issues that need to be investigated further. So it is crucial to refer back to potential causes or proceed with further diagnostic steps. In step 5, you will perform a check for any shorted wires in the NC line of the output shaft speed sensor. Begin by turning the vehicle to the off or lock mode once more. After ensuring that the vehicle is off, jump the shorting connector, SCS line, using the HDS to facilitate the testing process, and maintain this for at least 1 minute. Once this is done, disconnect the PCM harness, ADP connector, to have a clear measurement area. Proceed to check for continuity between test points 1 and 2, with the respective test points focusing on PCM connector, number 66, and a solid body ground. A successful reading of 1 MOQLO or more verifies that the NC wire is not shorted. If this reading is confirmed, proceed to the next troubleshooting step. If the measurement shows continuity, it indicates a short in the NC wire, requiring you to locate and repair the fault in that wire. In the final troubleshooting step, step 6, you will check for continuity between the NC line and the PCM connection for a clear understanding of the system's integrity. Make sure that the vehicle is still in off mode and that the output shaft speed sensor connector is disconnected, along with the disconnected PCM connector, ADP. Measure continuity between test points 1 and 2, focusing on female terminals number 2 of the output shaft speed sensor and number 66 of the PCM connection. An ideal result would be 1.0 ohms or less, indicating that the NC wire is in good condition. If you achieve this acceptable measurement, it's essential to check any authorized service information related to DTCs or the symptoms. Alternatively, substituting with a known good PCM can also determine whether the original PCM is faulty. If substituting resolves DTC P0721, you must replace the original PCM. If not, any open wire issues must be addressed to guarantee proper functionality. After completing the necessary repairs related to DTC P0721, it is crucial to perform a final repair verification to ensure that the issue has been resolved successfully. Start by clearing the diagnostic trouble code from the vehicle's onboard system. Following this, conduct a thorough test drive to evaluate whether the repairs have effectively resolved the symptoms and whether the check engine light reappears. Continue to monitor the vehicle for recurring issues to determine the efficacy of the repair work. It's also highly recommended to inspect any related connectors and wiring for signs of wear or damage to preempt future issues. Final verification is an essential part of the troubleshooting process, ensuring that your Honda Accord operates smoothly and reliably after any repairs. To prevent recurring issues linked with DTC P0721 in your Honda Accord, it is essential to adopt a proactive maintenance approach. Regular inspection of the wiring and connectors associated with the output shaft speed sensor is vital. Look for signs of fraying, corrosion, or any physical damage that could impede performance. Additionally, ensure that all sensor connections are clean and secure to avoid intermittent faults. If the manufacturer releases any software updates for the PCM, applying these updates can sometimes enhance sensor functionality and overall vehicle performance. Continued diligence in maintenance will help to extend the longevity of the sensor and wiring, thus ensuring smoother driving experiences. In conclusion, understanding and addressing DTC P0721 in the Honda Accord from 2017 to 2023 revolves around thorough diagnostics and systematic troubleshooting. This DTC signifies problems with the output shaft speed sensor that require immediate attention to ensure optimal vehicle performance. Following the outlined steps meticulously aids in accurately diagnosing and resolving the issue, whether through sensor replacement or wiring repairs. Additionally, preventive maintenance plays a pivotal role in avoiding future sensor-related problems. Regular inspections and updates can help keep your vehicle running smoothly and efficiently, thereby enhancing driving safety and comfort. By embracing these practices, you not only address current issues, but also fortify your vehicle against potential future failures. Please like and subscribe to the channel. See you next time.